Hello friends, welcome to my channel Lahari Lectures. In this video, you can watch notes on operating system structure. Operating system must be designed and organized carefully for the better performance and proper functionality in such a way that it can be modified easily in the future. Usually, it is preferable to have several small components of a system. Instead of having a single or monolithic system, each component should have a well-defined job and all the components are interconnected to form a single operating system. The following are the various approaches of operating system design. First one simple structure, second one layered approach, third one microkernels, fourth one modules based approach, fifth one hybrid systems. First one simple structure. There are several commercial operating systems which have simple but not well defined structures. Usually these systems were developed as small, simple and having limited functionalities, but their popularity grew behind their original scope. One such operating system is MS-DOS, which has developed keeping in mind that it should give more functionality within the limited space. Its structure does not carry careful divisions of its modules. MS-DOS has always experienced vulnerability towards threats and malicious programs which can cause damage to the entire system because of the improper separation between the interfaces and their functionalities. Due to this lack of security and protection, any application can easily gain access to the input-output operations and hardware of the system without any restrictions. In fact, the hardware, that is 8088 processor of that period, also provides no hardware protection. The earlier version of Unix also falls in this category. It divides the system into two parts: the kernel, which is also called as heart of Unix, and the system programs. The kernel contains several device drivers which interacts with the system directly. Later, the problem occurs in developing kernel because it became larger to implement as it has much more functionality. Application program, resident system program, MS-DOS device drivers, ROM, BIOS device drivers, MS-DOS layer structure. Application user compiler shell libraries etc. System call interface signals terminal handlings. File system swapping, block input output system, CPU scheduling, paging, virtual memory, kernel interface to hardware drivers, terminals, disk and devices, physical memory. Second one, layered approach. In layered approach, an operating system is divided into multiple layers or levels. The highest layer corresponds to user or application programs and the lowest or bottom layer corresponds to hardware. Each layer consists of data structures and operations which are invoked by its upper layers. A lower layer provides some services to the upper layer. The advantages of this approach is that construction and debugging become simple. As we know, the first layer, that is layer 0, is nothing but hardware, and if we assume that hardware is running correctly, then its services can be used by layer 1. Now the layer 1 is debugged and if any bug is found, it is fixed. The advantage that the errors can be fixed easily as they lie in that particular layer. Each higher layer simply uses the services of its lower layer without worrying about how the services are implemented by the lower layer. The limitation of this approach is that careful pre-planning is needed because a particular layer can use only lower level layers. For example, the device drivers of hard disks should be at lower layers than the memory management layer because memory management has to utilize the services provided by device driver of hard disk. Another major problem in layered approach is its inefficiency as it increases the overall burden of an operating system. Third one, microkernels. Microkernel approach is used to overcome the limitations of traditional Unix kernel. The kernel in Unix was so large that it itself became a monolithic structure, which is difficult to maintain. Microkernel approaches removes all the unnecessary and non-essential components from kernel, thereby decreasing its size. These non-essential components can be implemented outside the kernel as application level or system programs. The microkernel requires only minimal details about the process and memory management. Its primary function is to provide communication between user programs and various services running inside the user space. For example, a client program and a file server can interact indirectly by sending and receiving messages via microkernel. The advantages is that it provides flexibility and extensibility. Any new service can be added to user space without modifying kernel. It also increases portability of operating system from one machine to another. It provides security and protection because most of the programs are running at user level instead of kernel process. The examples of microkernel operating system are True64, Unix, etc. So this is the architecture of typical microkernel. Application program, file system, device driver, messages, interprocess communication, memory management, CPU, scheduling, microkernel hardware. Fourth one, module based approach. It is the best approach of operating system design which uses object oriented programming techniques. In this approach, various components of operating system are implemented as dynamically loadable modules. The kernel consists of core components and dynamic links to load those modules either at runtime or at compile time. Operating systems such as newer versions of Unix, Solaris, Linux and Mac OS X all use module-based approach. The Solaris operating system has 7 loadable kernel modules. Core kernel, CPU scheduling, file systems, loadable system calls, executable format streams, other miscellaneous modules, device and bus drivers. The kernel consists of core and other services like device drivers of certain hardware, various file system support, etc. These can be added to the kernel dynamically when needed. The approach is similar to layered approach, but it is more flexible. When compared to it, the core services include the core communication among them, modules and loading modules. Fifth one, hybrid systems. Very few operating systems adopt a single strictly defined structure. Instead, they combine different structures, resulting in hybrid systems that address performance, security and usability issues. We explored the structure of 3 hybrid systems, the Apple Mac OS X operating system and 2 most prominent mobile operating systems, iOS and Android. First one, Mac OS X. The Apple Mac OS X operating system uses a hybrid structure. It is a layered system. The top layers include the Aqua user interface and a set of application environments and services. The Cocoa environment specifies an API for the Objective-C programming language. Below these layers is the kernel environment, which consists primarily of the Mac microkernel and the BSD Unix kernel. In addition to Mac and BSD, the kernel environment provides an input-output kit for development of device drivers and dynamically loadable modules. This is the Mac OS X structure. Graphical user interface, Aqua application environments and services are Java, Cocoa, QuickTime, BSD. Kernel environment, Mac BSD. Input-output kit, kernel extensions. Second one, iOS. iOS is a mobile operating system designed by Apple to run its smartphone, the iPhone, as well as its tablet computer, the iPad. iOS is structured on the Mac OS X operating system, with added functionalities pertinent to mobile devices, but does not directly run Mac OS X applications. The structure of iOS appears in below figure. Cocoa Touch, Media Services, Core OS, Architecture of Apple's iOS. Third one, Android. The Android operating system was designed by the Open Handset Alliance, LED primarily by Google, and was developed for Android smartphones and tablet computers, whereas iOS is designed to run on Apple mobile devices and is closed sourced. Android run on a variety of mobile platforms and is open sourced, partly explaining its rapid rise in popularity. The structure of Android appears in below figure. Architecture of Google's Android. Applications, Application Framework, Libraries, SQLite, OpenGL, Surface Manager, Media Framework, WebKit, libc. Android Runtime, Core Libraries, Darwin and Virtual Machine, Linux Kernel. Thanks for watching. Please like, share and subscribe my channel. Thank you.